and then viewing the.
I do that all the time. It'll make like, awesome. It makes it ramp up. Use a lot more processing stuff.
Oh, really?
Yeah.
Okay. So I guess we'll get started, and as people straggle in, they can join us. We are going to go over the homework from our last lesson. So I get that higher order functions and callbacks are maybe a strange concept. We're going to start using them immediately. I wasn't kidding when I said that they are used everywhere in JavaScript, and particularly in Node. But I think that will help solidify your understanding. It'll make sense why we have them. Because right now, some of our examples have been sort of contrived, and we're writing functions that take higher order functions, whereas in reality, mostly we're just going to be using functions that take higher order, that take functions. So we won't be writing them ourselves, and that's a bit easier. But it puts a practical face on it. So we'll go over homework, and then we're going to get an introduction to Node. So this thing that we use every time we type Node at the command line. Like, what the hell is that? Today we're going to find out. So, but first, Renee had a couple of announcements. Renee is sick, so she won't be here today. She's got some sinuses or sniffles or something. Please fill out the surveys. She was like, get everybody to fill out the surveys. Don't forget the surveys. It really shouldn't take that long. I bet you it takes like 10 minutes or something like that. Because did you not get it?
I got it, and then I think I
accidentally deleted it. Yeah, it's super short. It doesn't take long at all. Right there, it's just to give us a sense of how everybody is doing. So I will ask Renee if that's possible. Making a note for you, Kathy.
Because I saw it and was going to go back. And
yeah, there should just be a link that I can forward to you.
Okay.
We'll figure it out. And then Renee was wanting to know if we are okay with having this sort of like career fair jobs thing that we're planning at the end of this class occur the day after the last day of class. And so I believe the last day of class is August 6th. Yeah. So
Thursday night.
Thursday night is what it would be, August 7th. How does that work for people? Is anybody have? Raise your hand if you think that basically works, or you think you can make it work. So we want to make sure we can get like a majority of folks coming to it. So mostly any like complete perfect like no's. There's no way that can happen. I'm babysitting my mother's sick dog on Thursday night or something like that. So every Thursday night. I know, right? The bird. So. Okay, well, that's good. I'm going to go ahead and confirm that with Renee, and that will be the plan. So keep that on your calendars. Day after last day of class, August 7th, career fair. Let's get to know what kind of startups are here in Oklahoma City. So, and who's got jobs. Cool. Any other announcements? Anybody want to mention anything? Class related. Things going well at Prototech. So it seems like a bunch of you guys are doing that. That's awesome.
Zach helped out yesterday, so I want to say thanks, Zach.
Yeah, I'd like to thank Zach.
Sweet. Thanks. Yeah, thanks, Zach. Anything else? So we did office hours today. So I was there. I'll be there again on Wednesday. So feel free to keep coming to that. I'm hanging out. When nobody's there, I'm still doing work. So it's all right. So. Sweet. All right. So let's go over our homework. I'm on the OK Coders page. It's the JS object-oriented homework, which is somewhat of a misnomer because it also includes the higher order stuff. What I'm going to do, I'm going to clone this into a repository somewhere. So on my terminal, on my command line, I'll find a nice directory, a friendly directory, somewhere, directory. Right, and I go into that. In my homework directory, and then I can git clone this guy, and that just makes a copy of this repository and pulls it down to my computer, puts it in the directory, JS object-oriented homework. I can cd into that. And then what I want to do probably is edit these two files or check out the markdown, the readme from the assignment. And so read through each JavaScript file and complete this assignments it contains. Further instructions are provided. So I'm going to do subl dot. My trick for opening up Sublime for this guy. If you're on a Windows or another computer, start up Sublime and open that directory. And then I've got my higher order and my objects.js. I'll blow this up. Let's start with objects.js because the higher order is slightly more, I think, an intricate concept. And I think the object stuff using self is probably a little more straightforward, right? Was it self or this? I don't remember. This, excuse me. It's self in Objective-C. We were just talking about that. Okay, so number one, create an object with a name property We've already got that. And a getName method. The getName method should return the value in the name property. Okay, that seems simple enough. So I want to add a method to this function, or excuse me, to this object. I do a comma. Oh, before I do that, let's go ahead and see that all my tests are failing. So remember, I run the program with node objects.js, and I see that I have 3 tests that are failing. Okay, so object 1, I'm going to add a function. I want the function to be called getName, so it's like I'm adding another property to the object, except for that it's a function, right? Good. And then I want to return the value in the name property. Now, I can't just return OK coders like that, because then I'm kind of cheating, and if I change the name, it won't work. And the test, in fact, checks for that. It changes the name on the object. I can't just return name, because it's looking for that in the global scope. I need to associate the object that this function is on. That's the object's context, remember. And we do that with this dot. Like that. And now that will return whatever the name value happens to be. I think that's pretty straightforward, yeah. Running my tests, and sure enough, test 1 passes. Piece of cake. Okay, number 2, create an object with 4 properties, address, city, state, and zip. We've already got that. Add a function mailing address that returns a string composed of the 4 properties with the following format. Address and then city, state, zip. And so basically, you're writing a function that's going to access a bunch of properties on this and compose them into a single string. Yeah. When composing strings, use the \n escape sequence. So we had a brief introduction to this, but these are sequences for representing special characters in strings like new lines or white space or tabs. Pay special attention to the string formatting, because if you get the formatting wrong, pass. So maybe it was being a little picky there, but computers are picky. So, all right. So I want to add a new I want to add a new function, but it needs a name. The name is mailing address. It is a function, and I'm going to return some kind of string, right? The string will start with this dot address, then have a new line, then have the state, or city, excuse me, so this dot state, then a comma, and a space. That's what I screwed up on when I was doing this earlier. Then, and I'll put it on another line, this dot state, excuse me, this dot city should be right there. This dot state plus a space plus this dot zip. And that should accomplish what I am talking about here, right? So, and so again, I don't think that's too hard. Mostly the pickiness of getting that string formatting right. Have string interpolation unless you use templating, which is a real pain in the butt. Oh, is there? What?
If you use double quotes,
okay,
then you have string templating, because then you can use like, I think it's like a %n.
What?
Or %s. You can insert a string.
At the end of it? Oh, really? Okay, but I can't. It's not like I can just stick it in there in the middle of the string. I still have to do like some string formatting thing and then attach it to the end.
Well, no. So like you just, if you like console logging something, then you just have like whatever you want to have the, I guess, string template in.
Right.
The word you want to replace, you like double quote it.
Okay.
And then you have a comma, and then the word you actually want to replace it at the end.
Oh, okay, cool. All right. We'll stick with this for now, but that's cool that it can do that. I didn't know you could do that. So, does the yes, good. So I got my syntax right. This is a really good example of what a function on an object would be. Like basically, I don't want to write my own functions in some other part of my application that does this, because another part of my application might need to do the same thing. So instead, I stick it on the object, and now the object carries that function around with it anywhere it goes, and I can use it anywhere, right? This is an example, the one above is an example of what you would call a getter. So rather than ever changing name itself, you would always use, or accessing name itself directly, you would always use the function getName. And then you'd have setters as well, like setName, which would be responsible for updating the value. It's a little less applicable in JavaScript because I can't make this what's known as private anyway. But you'll see it in some other patterns where the properties are in fact hidden, and you must use functions in order to get access to them. So, and this is just another example, a slightly more complex function. Create an object with one property, age. We already have that. Method can drink. It's a function. Can drink should return true if and only if the age is greater than or equal to 21. So basically, I can say var equals, or let's say is 21 or older. I'm just going to replace this so it'll be a throwaway. This dot age is greater than or equal to 21. And if I want to be explicit, I could wrap that in parentheses like that. And so what do I know about this? This guy here is going to resolve to a true or false statement. This is a Boolean operation. And the result of a Boolean operation is always true or false. And then I can assign the result of that operation to this variable and then return the variable. So I will be guaranteed to be returning true or false with that. But this is kind of a throwaway variable. I'm not using it for anything else. So let's just get rid of it and take the expression that we're using directly and do something like that. And I should be able to check. Test 3 passes, and I'm checking against 2 ages, 18 and 45, so I know that that's working, right?
So you don't even need the return true or false. That was just a shorter way to do it.
That's right. Yeah. So I mean, you could have. I mean, so you could see other ways of doing this, like if this dot age is greater than or equal to 21, return true. Else, return false. But we already know. I mean, this is almost a little redundant, right? We already know this dot age is going to be true. So let's just return the result of that expression. Yeah. And there's great little tricks. I mean, as you're learning to program, you probably write something like this first. And then you go, oh, I could store that in a variable and then return the variable. And then you get to the third stage, which is the most concise. So conciseness is often a merit in computer programming, but not beyond understandability. You want to write code that you can understand. That's really probably the most important thing. And once you get good at programming, this is, I guarantee you, easier to read than this. In one line of code, and it makes very explicit sense. Whereas like somebody trying to parse this has got to parse 5 lines of code first. But you'll get the hang of that, and we'll be writing really slick-looking code like that with experience. So, all right, any trouble with this? No pun intended. It's not too bad. This is good. Everybody good on this stuff? So not as complex as the prototyping. We're not going to run into the prototyping very often, but we will probably take advantage of this in some places. So, all right, on to the more difficult stuff, higher order functions. So. Like I said, we're going to put these to use very quickly. So if it's complex, that's okay. You're going to get a lot of practice with it. I have a couple of mistakes here. I initially called this filter, and then I realized that select was the word I actually wanted to use for it. And so sometimes in the description, like I say select, and then other times I say filter. You may have noticed that. I've since updated that. I mean select. So. Okay, so what do we want this to do? Select is going to take 2 parameters. So let's just do this one step at a time. It's going to take 2 parameters, a data parameter that is an array and a callback parameter that is a function. We've already seen a function that looks like this, for each. Yeah, for each is very similar to this. Map is very similar to this. And if we're going off of those examples on the web page, so if I look at JS Advanced Functions class, functional programming, and scroll down here, I can get a sense for how we built up map, right? So there it is. So already we know that we need to have some kind of array, and I called it data, and then some kind of callback. So let's go ahead and add those to our function. We know that we need that. All right, select is going to loop through the items in the data parameter, calling the callback for each one. In this respect, it is. We already should know kind of how to do that. We can use our for each or our map as a template. We know that we're going to loop through each item in the array, so we need a for loop. And I can just copy that from here and paste it in. Okay, so I need a for loop. What is this for loop doing? It's setting a local variable I to 0 that represents the index of the element in the array. So remember, an array is a list of items. We can get access to an item specifically in the array by indexing into it. I want to start at 0, go up to however long this array is, array.length. Length is a property on all arrays. And then I want to increment this loop by 1 item at a time. So this will allow me to get access to each element in the list 1 item at a time, which I could do by saying var item is equal to array at the ith index, right? And now I have one at a time each item in the array. So if this were my array, when I is equal to 0, item is equal to 1. When I is equal to 1, item is still equal to 1. When I is equal to 2, item is equal to 2. 3, 3, and then 4, 5. Okay, so I know that I need to call callback, which I do like that. I just call callback. We know callback is a function. That's what this is, right? It's a higher order function, so I'm going to pass it a function when I actually use select. We're writing the higher order function itself. And callback takes, looks like I got a spelling error there, the item currently being looped through, so I should pass it item. And it returns, so the callback returns either true or false. And so what this function select is saying is, if you give me a function, callback, you must return true or false. That function must return true or false. So I'll go ahead and collect that in a result. Var result equals callback. And I'm guaranteed that result is going to be either true or false. If the callback returns true, then current item to a local array. If it returns false, it does not. Okay, so if my result is true, I'm going to do one thing. If it's false, I'm going to do something else. It says add the item to a local array. So like map, we're not quite transforming our data, but we do have some other local array, and we're going to do something with that. And so in map, how do we create a new local array? Inside the function, we said var new array is equal to an empty array. So I'm going to do that. Okay, what do I want to do? If the callback returns true, then select adds the current item to a local array. Okay, so I have the result of my callback. It returned true. I want to add that item to my array. So new array, somehow, I need to get my item inside that array. We have a couple of approaches here. I could say a new array at I is equal to item. This will result in a problem because in some cases, our result variable is going to be false, and we will no longer be adding an item to the end of the array. We'll be skipping some elements, some empty elements in the array. So we don't really want to do it that way. We could keep track of another variable, some like new I value that we increment as we go whenever we get result is true. But there's an easier way to do this. There is a function on the array object called push, which will automatically append whatever you give it to the end of an array for you. So you don't have to keep track of the index. You don't have to keep track of how big that array is. It keeps track of it for you and automatically sticks the item on the end of it. So I can say instead new array.push. It's a function. I want to give it item. Okay? And so what am I doing? I have this function here that is iterating through every item in whatever data I give it. It's calling my callback, and then my callback gets to decide if that item at that point in the array did inside of this new array by returning true or false. At the end of select, I can then return the new array. So when select is finished looping through each item in the data, it returns the local array, which now contains some of the items from data, namely those for which the callback function returns true. I think we kind of make it really explicit here, right? Select is selecting elements from the original array only when the callback function returns true when given that element, right? So we see an example of this. I have ages 16, 21, 30, 45, 60, and 75. If I call select with those ages, I also need to provide a callback function. This is my anonymous inline callback function. It is the responsibility of this callback function to accept an item one at a time in this array and then return true or false. It is going to return true only when the item is less than or equal to 25 and false otherwise. For each item in the array, it's going to be called every single time, one at a time for each item. So you can see like the control flow here is I pass ages to, and I'll keep it, ages to select. For var I is equal to 0, so basically I is less than ages.length, I++. item is equal to ages at 0, call the callback, which is this anonymous function right here, with the first element in this ages array, the number 16. If 16 is less than or equal to 25, return true, because that expression results in true. If it's greater than 25, return false. 16 is less than 25, so I return true. The result of calling callback is true. If the result is true, add that item to the array. And so now my new empty array contains one item, namely the number 16. I reach the end of my for loop, so I go back to the top and increment the I by 1. So now I'm looking at the ith, or the 1th element, second one, right? So I grab it, 21 becomes item, call my function here with 21. 21 is less than or equal to 25, so I return true. Result is true. Add that item to the new array. Reach the end of my loop, increment I plus 1. Now my I is 2, so I grab 30 out of the array, stick that in item, call callback with 30. 30 is not less than or equal to 25, so I return false. If false, I don't do anything. I don't change new array this time. And every other number is greater than 25, so that will be the same result. So by the time this is done, every element in this thing has been sent to this function right here. And this function gets to decide, this anonymous inline function ultimately gets to decide which elements are collected inside of new array. The goal of select is to abstract out this need to keep track of the local array and iterate through every element inside the original array I pass it. I don't want to write this code every time I just want to do this. But I still need to be able to do this stuff here every time, right? I need the details in the abstract. This is the abstract, this is the specific. Yeah? And so that is what a higher order function basically allows us to do, right? We pull out some code that we keep the same every single time, because that's what a nice algorithm does. But we allow ourselves to interject some functionality inside. And that's what our anonymous inline function is right there. Okay? That's mind-bending, I get that.
Why did you do the blank else? Is that just to show?
Yeah, just to be explicit. So let's clean this up. Let's make this a little simpler, right? So good question. I don't need a blank else. I'm not doing anything when it's false. Boom, so I get rid of it. Okay. I don't really need to store item from the array because I'm really using it here and here. I can just make a direct reference to array at I, right? So I can grab that and replace item with it. And that gets rid of that variable. And then honestly, I don't really need to restore or store result of calling this callback because I'm only using result here. So let's go ahead and replace result with the expression for it. Get rid of that. Get rid of some white space. And now we have a very nice, clean function that is quite a bit denser, but sort of is that concise, readable effect that we go for. Yeah. Otherwise, it's functionally identical. And so I can save this, run my higher order at this point, and my first one should blow up because I called it data, not array. And test one now passes, right? So that's mind-bending, I get that. We're probably not going to have to write our own higher order functions for the rest of the class. We're going to use them right away, like I said. So we're going to do this part of this assignment instead of this part of this assignment. And this part of this assignment is noticeably more straightforward, right? I just give it a function, and I trust that it gets called at some point. So, questions about that?
Can you post your answer in that intermediate step somewhere? I mean, I'm gonna have to go through that a couple more times.
Yeah, sure. Let's back that up then. Okay, and make sure I get my names right here. Data, and that's it. Make sure it's passing, and good. So, and that's been asked before, and I keep failing to post these things. Post solutions to assignment. Yeah, trust me. The first time I went through this, and I went through it in the Eloquent JavaScript book. That is when I learned about higher order functions, and it was seriously like a year and a half ago, and I was just like, what is going on here? This is crazy. But I tell you, once you get it, you're like, it changes how you think about programming. So, because what you'll find is that in previous places where you had to write a ton of code over and over and over and just change a little bit, you can wrap all of that code up inside of this abstraction and then include the little part of your algorithm that needs to change every time as a callback. Very powerful stuff. So, okay. Create a reject function that works as a higher order function is the opposite of select. So instead of selecting items from the array, I now want to reject them. And so I kept the exact same array, and basically I'm saying give me older people if older than 25 is considered old. I like to think I'm still young. So it's just the opposite. I can let's literally copy and paste what I did in select. What do I need to change? What is the only thing that needs to change? Go ahead. True, false. That's it, right? So I can say if not result. Reverse the value of this expression. So now, I know it's weird, but if you say not true, well, not true is false. And so this whole thing will evaluate to false if result is true and won't get called. Good. But if result is false, that means that we do want to reject it, right? Then this will result in true, those are the not result, and then we will get added to the array. So it basically does the opposite. We've changed one logical expression. That's it. The power of logic. So let me ask you another question. So not to confuse you anymore, but where have we seen this before already? Where we need to loop through an item, grab that item in the array, and then call something about that item.
Wasn't that the for each loop?
For each loop, right? So really, if you want to really blow your mind, figure out how to write reject and select using for each. Use for each as the higher order function that does the looping for you, rather than writing the loop itself, right? Because that's what for each does, it loops for you. That will even be a little more mind-blowing, and you might add console.log to it to see where things are, getting called and in what order. But it's very possible, and it will clean up your code even more. And that's the point of functions. Functions, you use functions and other functions to build up on, previous abstractions. So, all right, let's make sure this worked correctly. No, it didn't, because here I did not provide the data or the callback. So once again, data and callback. Right? Forgot my parameters. How come you guys didn't catch that? And test 2 passes. Whew. All right.
What?
Huh?
Catch what?
Catch what? The fact that I left off my parameters. Okay. Create a find function that works as a higher order function. Again, find takes 2 parameters, a data parameter that is an array and a callback parameter that is a function. Okay, we know that. So data and callback. Find should return the first item it encounters, for which calling the callback with returns true. Got some redundant English there. With which, boy, all kinds of redundant English. Counters for which calling the callback returns, for which the callback returns true, whatever. If the callback never returns true for any of the items in the data array, it should return undefined. Okay, so we know that we're looping through all of our items again. So, in fact, this is going to be very similar to what we were doing with select. So I'm going to go and loop, and I'm going to grab this result of the callback and everything. So I'm just going to copy paste that. Okay, good. If find return, or if the callback returns true, return the item for which callback returned true. So if my result is true, I want to return the item itself. So what am I doing? I'm like searching through this array, looking for a match to whatever my callback function is specifying. And when I find that match, I'm going to return the item itself. We can see this with the usage. I'm saying, hey, find the first even number. How do I know I'm looking for the first even number? Because my callback to the higher order function tells me that. And so it's going to see 1, result will be false, 89, result will be false, 45, result will be false, 26, boom, result is true. If the result is true, then I'm done executing and return the item itself. So first even ultimately becomes the number 26. If I reach the bottom of my function, I should return undefined. So if I iterate through every item in this array and I never return, so maybe worth mentioning, one of the consequences of returning is that you return immediately from that function. As soon as you return, no more code inside this function gets executed, right? Even if you're inside a loop, kills the loop. So returning immediately executes. If at no point I immediately executed, and the only way that could happen is if I've looped through every item in the array, then I've reached the bottom of my function, and I should return according to the specifications, undefined. Even though we're making explicit what is already happening implicitly, right? If you call a function in JavaScript that does not return a value, its value is undefined. So. Save that. Now I have 3 tests passing. I will definitely make this available. So, because I definitely understand the difficulty of wrapping your head around this. This stuff is legitimate. This is the hardest thing that we cover in this class. So, I mean, if you make it through this, you've made it through the hardest thing that we cover. Everything else from this point on is just writing JavaScript. So it's reinforcing what we've learned. The hard stuff now is figuring out what APIs to use. We'll learn what an API is in a second, which is basically reading documentation. And how do we best organize our code, which is a question I don't even know how to answer yet when it comes to Node. I don't think anybody knows how to organize Node code. I'd love to hear what Maya has to say about that. It's hard, because there's no best way to do it, right? It's very open to however you want to do it. So maybe that'll be your lecture. Okay, so let's pause for a second. Any questions about this, besides the fact that it still doesn't make any sense? Think about the language. We get what loops are doing, accessing arrays, calling functions. Remember, break these down into their simplest component parts. Ultimately, all we're doing is loops, which is a basic control structure, dealing with a few variables and calling some functions. If you get those 3 parts, then it's just a matter of putting them together in the right way in your head to get what the program is doing with those basic parts. Yeah. Okay.
When you do the return item, does the code stop executing at that point?
The function immediately exits. That's right. Return automatically stops anything that's happening inside the function from happening again. So, okay. Yeah, returning. So being explicit about that, which I should have mentioned somewhere. Returning does in fact end execution of that function, no matter where you are in it. Yeah.
You don't need a break. Yeah,
don't need a break. Although a break is a totally legitimate way of approaching this problem. So, yes.
Yeah, so sometimes people will just execute their callback, and they'll think that that function is done, but then it'll keep executing lines after that. So sometimes even when you want to just execute your callback, you should return the callback executed.
Okay. So how would that change here?
So that function is totally fine, but if let's say in that if right there.
Oh, if they're returning callback like that.
So
oh, right.
It would be so if you didn't have anything below that, you could just say callback, in the parentheses. And people do that a lot, and they assume that nothing below that's going to run. Sometimes it's true, sometimes it's not. So it's good to use a return keyword.
Do you have to put return undefined, or would it?
No. So we're just making explicit what this function would do in that case, because as you're right, a function in JavaScript, if you don't return a value, is undefined, right? That's what it evaluates to.
What would be the best practice in that scenario, to return undefined, or let the software do it for you?
I don't know. I once you've worked with JavaScript a lot, you don't have to think about the fact that a function evaluates to undefined if it doesn't return anything. So you don't really need to see that.
The only one writing on that code.
Then it might be nice to make it explicit. So you're basically documenting what this function does when you explicitly return undefined. And some people might say, I don't want to return undefined, I want to return null, which is another way of saying nothing is here. But that's different than undefined. Undefined means I haven't addressed this yet. Null means I addressed this and it doesn't have a value. Null is no value, whereas undefined is don't know, right? Both null and undefined evaluate to false when you use them nakedly in a if statement, so it would work either way, right?
That was going to be my question. Why did we return undefined instead of false, for example?
I mean, false wouldn't be what you want to return here, because find actually is supposed to find an element, and what if your condition is finding the first false element, right? That would clearly be an error. So I think it's right to return either undefined, which was we didn't find anything, or null is probably even the best option in terms of being correct, because we do have a value. It's no value. We didn't find anything. We know that. So maybe null is better here. Cool. Good questions, though. Yeah, Brent.
So it doesn't. The callback doesn't really return true unless the return statement in the return item too.
This guy. That's no. That's right. Right. So, I mean, otherwise callback will return false. Callback is always returning something, though, right? Because we're explicitly calling return inside of it. So. Whew. All right. Let's put that aside for a little bit and take a breather. All right. I am now looking at the material for our Node introduction class. So it's this guy in our GitHub repo, and I'm pulling it from Intro to Node. And this lesson is not that long, so we're not going to rush through this one. We're going to move a little bit slower for today, which is probably good, all things considered. And then we're going to pick it back up next week. But like I say, picking it back up is really a matter of just knowing what to use and what to write rather than needing to learn anything new about the language. We're not going to learn any new programming. We've learned everything we're going to learn about JavaScript. Now we need to learn about Express and Node and these programs that we've been using the whole time and what kind of services they provide for us. So you will find a couple of example files inside of this lesson. So if you look in our examples directory, this is the material that we're going over. So like I've got this readfile.js, which contains some JavaScript and a bunch of comments in it. So read through that and make sure you can understand it after this lesson. This is code that we're going to be going over in class. It's all in the examples. And the README file inside of this repository explicitly sort of says what this code does and how you use it, and the different ways of using some of these examples. So, so as a helpful, like, here's some material that we worked on in class type thing. But otherwise, I'm reading this Intro to Node. So, okay, so what is this thing that we're typing at the console all the time, Node? We've been using it as a REPL, or read a value print loop, when we type it by itself. So we know what that means, right? When I just type Node, I get this greater than sign, which lets me type JavaScript into it, and it executes that JavaScript for me, one line at a time. But if I give it a file, so if I run a file, it actually executes the JavaScript in that file, right? So we know that Node is a program that can read JavaScript files and turn them into an application somehow. Yeah, this is called an interpreter. Rather than, say, a compiled program, JavaScript programs are interpreted. That means we can leave them as plain text, and then Node will figure out what to do with them as it goes, rather than actually creating an actual program that the computer knows how to run. There's this intermediate layer in there. I don't think that's a critical detail to know for now, or like what the difference is between interpreted and compiled code. But just know we write plain text JavaScript. Node can figure out what we mean and makes an application out of it, makes a running program out of it. But Node is not just this program. Node is like this entire environment for doing JavaScript programming on a server. So in the past, JavaScript only really ran on browsers. If you wanted to write JavaScript, you made a script tag inside of your browser, and you put some JavaScript in it, and it moved some HTML around or flashed, something on your page, right? With Node, we can still write JavaScript, but we can have programs that run outside of the browser. Our programs are now running on the command line, which is a little crazy, right? Node took the JavaScript implementation from Chrome and added a bunch of low-level access to operating system functionality, like reading files or creating files or making connections to other computers over a network. And then it exposes all of that functionality back into JavaScript. So it gives us what are called APIs, Application Programming Interfaces, which a term I'm going to use a lot, that let us do those kinds of things, like connect to other computers or read files. And all those are is functions. An API is just a function that the operating system or that the platform or Node or somebody else provides to us, right? So when I say console.log, where does that come from? It's in JavaScript. It's in Node. That's an API, right? When I use an array, where does that come from? I don't create it. It's built into JavaScript. It's built into Node. That's an API, Application Programming Interfaces. And so Node, in addition to being the program which interprets our JavaScript and runs it, is also the collection of all of these APIs. And Node provides quite a few useful ones to us, and that's what we're going to look at today. How do we use Node? How can we do cool things with Node more than just like writing silly JavaScript functions? There are also some essential concepts that we need to wrap our heads around that we will see everywhere inside of Node. or everywhere inside of programming with Node. And so we're going to talk about some higher level type stuff that we want to sort of familiarize ourselves with, and then we're going to go over some practical uses of that higher level stuff. Okay? And the first higher level concept that we want to talk about is asynchronous programming. And so we've actually already seen this, but I want to cover it in a little more detail right now and then get to using it immediately. So asynchronous functions are functions which run in the background. So when the function completes its task, so after it's finished running, it will call back into the code that you've provided, which then handles the result of that operation. But in the meantime, the rest of your program keeps on executing, right? And this is what callbacks solve for us. This is why we have callbacks. So let me real quick create a test.js file. Actually, it should be in there already. Nope. Okay. Let's say I have a program, or if it's like I'm doing something. So I have this function foo, it does something. And then I have this function background function, and it does something. And then I have another function bar, and it does something. And background function is going to run in the background, which means the rest of my program can continue executing even as this thing is doing what it does, like accessing the file system or making a network connection. And so when I call foo, foo has to finish doing what it does before the next bit of my code can be executed, right? Then I call background function, and background function immediately returns control to my code so that bar is executed. But background function is still doing something even though I've reached the end of my code. And when background function finishes, it needs to let my code know that it's finished and give it the results of whatever it's done. Normally, we get results back from a function by just assigning it to some variable, right? But we can't do that. If I try to do that with background, result is going to be undefined because background doesn't return anything. It needs to finish what it's doing after it's already returned. So how do I get the data back from the background function? How is my code going to be able to do something with the stuff that the background function provides to me? A what? Well, I mean, internally it might use that, but I need to provide some of my own code to the background function. How do we do that? Callbacks, right? That is what a callback is. It's code that I am providing to a function that function will eventually call at some point later on in the execution of my program. It will call back to my code. And so I will provide to background function probably something that looks like this. And then in here, I will have access to the data that background function provides. Where's that data going to come from? As parameters to my callback function. And so typically you're going to see two parameters, an error parameter and a data parameter. If something went wrong, background function will send some kind of error value to your callback. If everything went okay, that'll be false or null or something, and then it's going to send you data. And now I can do something with that data. So that the order of execution in my code is now first thing, foo, second thing, background function, but this code doesn't get executed. So if I have something in here like console.data, console.log data, that won't get executed. Instead, bar will execute first, and then when background function is finished, it will call my nice callback here, and then I can do something with that data like log it to the console. So it goes 1, 2, 3 instead of 1, 2, 3. And that is known as asynchronous. In a sense, it's like out of the order that you would expect it to be if it were running in linear time, right? It's like out of time. Rather than 1, 2, 3, it's 1, 2, 3, right? Asynchronous functions. And this is what we use callbacks for in JavaScript, and this is why people like JavaScript, especially for web development. And so what makes Node, like I say, so popular is the fact that it will do this, and this works really well with long-running operations. And so let's say I've got a web server. Oh, first of all, let me fix this, because otherwise I will lose my power. And let me say that a long-running operation, so when I talk about a long-running operation, this thing's so old. like me. I'm going to talk about a long-running operation. Long is a very relative term. How long is long for a computer? 10 seconds is extraordinarily long for a computer. How much? Milliseconds is long for a computer. If something takes dozens of milliseconds or hundreds of milliseconds, that is really slow. What kind of things take dozens of milliseconds or hundreds of milliseconds? Accessing a disk or connecting to a computer across a network. And those are both things that a web server has to do all the time. Now, when a program or any programming language, any running program, needs to do a long-running operation, it normally has two options. And so let's imagine this in the guise of a web server. I've got my web server running, and somebody connects to my web server and requests a file from my web server, or requests a database access from my web server. Those are both long-running operations. They're going to take a little bit of time. Normally, my program can do one of two things. It can do that operation synchronously. So basically, it can run that code and block the rest of my program from executing while it's running that code, which is how normal code works. That's how foo works, right? That's how bar works. That's how normal code works. And when a function only takes like nanoseconds or you know, fractions of milliseconds, no big deal. But if a function takes, say, 100 milliseconds to run because it's reading a file from the disk, namely the file that the person browsing to my server accessed, my program cannot do anything else for those 100 milliseconds. And you think, no big deal, 100 milliseconds. Why is it going to need to do anything else in 100 milliseconds? Because during that 100 milliseconds, another of the 3 billion people who have internet access in the world, are maybe 1,000 of them are trying to access my site at the same time because I'm Reddit, or I'm Facebook, or I'm Google, right? And so if I need to take 100 milliseconds for 1,000 people who are accessing my site all at the same time, my computer is going to take many seconds to reach the last one of those requests, the last person trying to access it. And in the meantime, their web browser might think that something has gone wrong with my server and drop the connection and simply not get anything back from my web page. And so now I've failed to respond to that person with my server, right? Our other option is to spin off a copy of this code in the background and run it on a separate thread. And so, I mean, we don't need to understand how threads and stuff like that work, but basically I get to make a copy of my code and start it up in another process and have that thing answer the request, right? And that works pretty well. That's what Apache does if you've ever used Apache. Maybe that's what ISS does, maybe if anybody knows. That would be my guess anyway, the Microsoft's server system. That's a pretty decent solution, because now my main process over here that's handling all the requests can sort of like send off handling specific requests that take a long time to other processes, other copies of itself. Well, it can continue to handle new requests, right?
Like cache.
No, caching is saving the result of an operation, which is a strategy that you can use to make this faster for sure, but it's a little bit different. These are like helper processes that run separately. And while this one is doing something, this guy can get a new request over here, my main one, and spin that off in a separate request as well. And then handle a new request and spin that off in a separate copy of itself as well. And so now let's say 1,000 people try to access my site at the same time. No problem. I'm going to make 1,000 copies of this code and run it on my computer. That sounds pretty good, except for that my code might occupy 2 to 5 megabytes of memory. Doesn't seem like a lot. Except for that there's 1,000 requests at the same time, and now I need like 5 gigs of memory. And my server does not have 5 gigs of memory, so my server grinds to a halt as it pages out memory to the disk, which is how virtual memory works. And then I've got this doubly slow operation, because now I don't have enough real memory to handle processes, and they're getting saved to the disk. And then maybe even my server crashes because it's run out of memory for handling its main process. And now I don't have a server running at all, right? Those are our two solutions. Node bypasses both of those and says, you know what? One, I'm not going to run this synchronously. I'm going to run it asynchronously, so we are going to do it in the background, but we're going to do it without making a copy of our code. And so we're still going to use threads or whatever underlying way it's done in the background. It's pretty neat. Have you looked into that stuff, Milo, like how it does it in the C++ stuff? It uses some kind of operating system callback thing that's I don't quite understand. No, it's not threading. It's a little bit different.
I know it uses events.
Events.
So it just, like everything it does, it basically just handles it and it waits for the next event.
Right. So it's got an event loop running. But like there's some special library on Unix or in Linux that handles this stuff now at a very low level. So even though we're still like doing stuff in the background, it requires a lot less memory. We don't need to make an entire copy of our program. There's some very low system level type stuff that's doing it for us, and we might use kilobytes of memory instead of megabytes of memory. So now we can have one bit of JavaScript programming server stuff that can handle thousands of simultaneous requests on a very basic computer. And people love that, right? And the advantage, if you like JavaScript, is you can now write web servers in JavaScript, whether you need to handle thousands of requests at the same time or not. Let's see how that works. So I'm going to blow this out. And there's a really fantastic example of asynchronous access with callbacks using the file system API. Yes?
So the punchline is it speeds things up by not doing more than it needs to?
Yeah, in a sense. Yeah, I would say so. It accomplishes the most with the least amount of resources. So it solved a nice little optimization problem using some underlying C, C++ jujitsu. Okay, so let's see asynchronous. Like I say, Node provides these application programming interfaces that we want to use in our code. They come in the form of modules, which we're going to learn a little bit more about in a second. But for right now, let's just look at using a module without understanding what a module is. I do this with the require statement. So I can imagine this is a Node program. I can require a module by calling the function require and passing the name of the module or its alias as a string. And so FS stands for file system. So this is going to give me access to the file system APIs, and I want to store that in a variable. So I'll just call, say, var fs equals require fs. And now fs is like an object, like any other object we've seen in JavaScript so far, that has functions attached to it that I can call with dot notation, which we've done with our objects, you know, just a second ago. One of those functions on the fs object or inside of this fs module is called readFile. So I can say fs dot readFile, and it's a function, and it's going to read a file for me. It's going to actually pull the contents of that file and give them to me in the form of a string. Before I do that, let's create the file that I'm going to read. And so I'm in here, test.js. Let's be meta about it. Let's read test.js. Yeah, we can do that, I think, right? So what file am I going to read? ReadFile is going to take two parameters. So it's a function. It takes arguments. The first one is the name of the file, test.js, or whatever it happens to be, right? And then the callback. Okay, readFile is an asynchronous operation. It returns immediately and allows the rest of my code to continue executing because reading files takes a long time. But when readFile finishes, it needs a way to let my code know that that has happened and let my code work with the information that comes. So I need to provide it with an anonymous inline function in this case, whose first parameter is error and whose second parameter is the contents of the file. In this case, it'll be a string. It'll be a buffer that we're going to convert to a string, but we don't need to worry about that. Okay. So module fs function on that module is called readFile. ReadFile takes two parameters. One is the name of the file I want to read. The second is the callback function that will be called when readFile completes. The callback function itself, according to the documentation, takes an error and the data. How do I know this? Because I went to nodejs.org, which is the home page for Node. I looked at their documentation, and I looked at their file system API, FS. And sure enough, there is a, somewhere in here, readFile function, right there, that shows me how to use it. Your homework this week is basically doing this. Looking up stuff in the documentation and writing code according to the examples that it provides. Because that's how you learn this stuff, right? You might read a book. I read a book. But they do a pretty good job of showing me what I want to do. And as you can see, fs.readFile, name of the file, callback function that takes error and data. And then somewhere in there, I check for the error, and if it works, great. Or if there's an error, I should do something. Otherwise, I can log the data. All right? So let's do that. So I'll say, if there's an error, we don't want that. I should let the user know. I'm just going to say console.log couldn't read test.js. Otherwise, let's get the string from that, or the contents, the string contents from that data object. We use a special toString method on it. So basically, data is raw byte data. I want to convert that to a string, so there's a toString function on it. I know that from looking at the documentation. And then I can console.log that content. So it'll just output the contents of that file, right? Reading the file, asynchronous operation, needs the callback function. Check if there's an error. Let me know if there is. Otherwise, let's spit out the content. So I'm just going to read this file. This file is going to read itself when it executes and print it out to the screen. Let's see if that works. What's that?
Like when I did it, it returned a buffer.
Right, that's why you got to call toString on it. Right, yeah. Your other option is to provide a middle parameter here that tells it what the UTF-8 is. Yeah. Yeah, so did I. I was like, why did I get a buffer? Look at the documentation. All right. Node, so I'm going to run it with node test.js, and boom, it reads the file itself and prints it out to the console. What does this look like? What command line utility does this look like that we've been using?
What?
No, oh, close. Cat, boom. We just wrote cat. Well, a simplified version of it. But that's basically what it does, right? Imagine if I could give test.js a file name and then read whatever file that was, because I can get arguments from the command line. We've actually seen that already. That's going to be one of your homework assignments. Make it so that I can call node with the name of the file, reader.js or whatever I called it, and then provide a file name afterwards. It gets the file name from the command line and goes and reads that file and prints it out to the console. And so we talked about using less. It won't quite work here, but we could, in fact, pipe the results of that operation to less. And now that output is being sent into less, right? And I can use less to look at it. So if this were a longer file, that would work. Just automatically works with the way that Unix is set up. So now, this is really not all that magical, you might think. Just about any programming environment that I use is going to let me read files. Big deal, right? If I can't read files, what is the point of that programming language? So just about every platform will let me do that. This is interesting because it is asynchronous, although we can't really see that explicitly. So I'm going to add a couple of console.log statements to show you what makes this special. So to actually visualize how it's asynchronous, I'm going to add a console.log statement at the front here. So before I call my function, console.log, about to call read file. And then after it, I'm going to say console.log called read file. Right? And let's pay attention to the order that these things appear in. About to call read file is first. Called read file is second, even though it occurs after my call to read file, right? That's because it's asynchronous. This function returns immediately. This code does not get executed until later on. So I see a called read file afterwards, and then finally my callback is called, and the contents of the file are printed to the screen. Yes?
You can show them like the synchronous version of that, maybe.
Yep. I include that in the sample documentation, and I think we should do that right now. Yeah. Yeah.
Quick question. Is there any way for us to specify if a function should be asynchronous or not asynchronous?
So that's kind of what Mayo is suggesting. The way Node works, by default, almost all long-running operations, so file operations, network operations, are asynchronous by default. This is how they work. But Node typically provides a synchronous counterpart that will block the program until it finishes executing. And so if I look at the documentation, there's this read file function, but there's also this read file sync function, which is the synchronous version of read file. And it will simply return the contents of the file name. It doesn't need a callback, right? It gets the stuff, blocks my program until it gets the stuff, and then returns those from the function. So if I wanted to do it the different way, instead of having all of this stuff here, let me block that out, I can say data equals fs.readFileSync, and then just give it the name of the file, test.js. I don't need a callback now, right? Because this function will finish executing synchronously and then return the results. Then I can just log that to the console, console.log, data.toString. And now we'll see that the order is what we would expect it to be. About to call read file, output, called read file, right? Because it's synchronous, because that function finishes executing before the rest of my program executes. Yeah, there's the difference. If you're writing like a command line program, it can be easier to do stuff synchronously like this. When we're writing web applications, we're not going to do anything synchronously. Every bit of our code is going to be asynchronous. All of our code, all of it, is going to look like this guy here with callbacks. Sometimes we will have nested callbacks. That's not necessary. I mean, it's necessary, but it doesn't have to be so messy. So remember, what is this? This is a function, right? This is a callback function. I could explicitly give this function a name, right? I could cut out that code and make a function called reader callback. Let's do var reader callback equals that function. Yeah. And then now for my read file, I can just give it that callback. Remember, this is the exact same thing. Yeah. This was the way we first learned how to do it. But sometimes it can be easier just to embed this part directly in here because that's what it refers to. Eventually, you might have lots and lots of callbacks happening inside of callbacks. That's called callback hell. That's what I was just mentioning. And then for readability, it can be a better idea to explicitly break out your functions like this and then provide them in here. So it goes back and forth. I've seen arguments for and against. I think whatever improves your readability is probably best. So. Okay, is that clear? So we got asynchronous file operations, like out of order in a sense. Any questions about that?
So does it call the callback once it's done reading the file, or is there like some type of way to set the time when it's going to call back?
In this case, when it's done reading the file, it'll do the callback. Yep. So there are, and in fact, your program will continue executing or continue running. It'll be in memory until that callback gets executed. So we're going to talk about the event loop in a little bit. There are other stream operations that can read bits of a file at a time rather than in one go. And then you'll have a callback that gets called multiple times as you read in parts of the file. But that's a little more advanced, and we're not going to go into that. So. In this one, yeah, it finishes it, and that only when it's finished or an error occurred do you get the callback. So. Any other questions? Do we see how we're using this already, though, right? Imagine read file. Imagine writing read file yourself. It's going to look a little bit like that select or that map or that for each or whatever, except for it's not looping. But it's going to get a callback somewhere in there and have to call that callback. Yeah. Internally, that's what's going on. Really, we need to understand how that works and why we use callbacks like this. So. And this is in the example code. So that sample that I showed you, that's part of the repository. So if you look up at the examples up here, and you look up at readfile.js, there are two ways of doing it. The asynchronous way, as we just did it here, and then the synchronous way, which is the other way of doing it. Right? So you can see both of those. That's in today's homework, or today's lesson material. All right, let's take a break. We're at the hour mark. 5-minute break. We're making good time. I think we'll cover the rest of this. So grab something to drink and eat. Be merry.
So this is what I was talking about when I was saying the thing with like, and so like this is a common error. Like you'll just say callback, and they'll think that'll be done, right? Rather than saying return callback, because it's still going to return. Like,
yeah, it'll still go down to there. Yeah.
So yeah, that's what I was talking about. It's a common error.
Cool.
Yeah.
Yes.
What's the string interpolation thing?
Oh yeah, so I'll just do that right here. So you can say console. Really?
I don't know.
And then let's say we want to say
let it go out, man. Just let it flow.
And then
Oh, yeah.
percent S.
Let the air flow.
Okay, and then comma.
Yeah.
Okay. And then however many percent S's you have, it'll go in there.
Yeah. So like,
That's not too bad. Can you assign to a string like that?
like could that be a variable?
Could I do, man? Could I do like var string equals Bill is a percent S. And, I guess it's a quote. Right?
I guess it can't work.
That's good. Yeah. So it has to be in the console statement.
I guess.
Cool. Yeah, Ruby has this thing where you do something like this. So I could say var gender, say is equal to man, and then I would say in quotes Phil is a, and then dollar like that, and then I can just provide the variable that I want it to evaluate inside of the string. It's almost like templating, but built into the programming language. It was like, I would cover that in JavaScript. Cool. Yeah, I didn't even know you could do that. I'm sorry. Cool. Thanks.
I'm just the only one that does it at my office. So I take it. Yeah. But people are usually scared of doing it, so I'm just like, because they've seen all these movies of people just filling it, which never happened.
I love the tea. I love the potato. So this is Korean.
Oh, yeah. Have you looked at the roster?
Is that Chinese?
Look at the roster.
Yeah. That's Chinese. In Chinese.
So,
It's making notes.
It's two parameters. Data and error.
I go as make error and data everywhere.
What happens to has to call back?
Oh,
Yeah.
I know when you sample
It's basically the same thing, but in the command itself,
yeah,
callback, they don't say.
They don't tell you what it could change.
Yeah, I mean, is that just how they format it, or?
I think it's just how they're formatting it in the documentation. Really? Because they're showing that parameters, like when I call read file, it can take, it doesn't have to take 2 parameters, it could take 3 parameters. And there's different ways of passing arguments into read file. And so when it shows that in the documentation, that's all it shows, what you're allowed to give that. And then I guess if you look at the details, it tells you what callback actually has. Now the thing is, if you give it a callback that does not take parameters, it'll still work. Unlike other programming languages that are like strongly typed, JavaScript doesn't freak out. It'll let you call it. You don't have a way to access what returns my name, but you can access it using a special arguments keyword or arguments variable, which is implicitly available inside of it. It's kind of like.
So
I'm gonna add
also,
to
I guess in short, it does imply here, like it does.
Yeah, really it does.
branch
Okay.
it. Yeah, I'm
So
gonna
it
go
doesn't explicitly show
right.
that.
And then it changes there,
That's
and
sort of
then
shorthand
just
for the working file or what that is.
Okay, that's what I'm really curious about.
Yeah, they're even weirder in underscore. So if you ever look at like the underscore documentation, they do it the same way. They're like, callback, hey, what do I need to do? I just look at this underscore.
look at it and whatever you don't understand, ask me. Okay, I'm in the, okay, so I'm gonna make one commit to it. And you should get an invite on.
Things can't be that good for you, right? Okay, let's bring it back.
It's got 3 grams of protein.
I guess that's not crazy. All right. That's a very brief introduction to the file system API. You can see everything that the file system does by looking at the documentation. I mean, basically, any kind of information that we need to get about a file or a directory on our computer, Node provides a way to do that. And in fact, so for your homework assignment, you're going to write a more advanced version of what we just did here that lets you choose which file you want to read. And then you're also going to write a program that copies files. So you can copy from, you can write, you'll see that in Node you can also write files. You'll have to use nested callbacks to do that, like to check if your write operation succeeded. You have to do the write inside the callback for the read, right? So that'll be fun, and maybe tease your brain a little bit, but otherwise not too crazy. Just check out the documentation and look for examples on Stack Overflow. So have we mentioned Stack Overflow explicitly yet? I know some of you guys know about it. Explicitly. Let's say I go to Google, node, write file. First result is on a web page called Stack Overflow, which is it's even above the node documentation, right? So really, I should go to the node documentation. StackOverflow.com is like a place where programmers hang out and ask each other questions and answer the questions for each other. So it's a crowdsourced question and answer site for programmers. And so these guys are like, how do I write a file in Node? And this guy's like, look at the documentation. Also, here's how it's done, and I copy the documentation. So if you're doing basic stuff and you ask questions on here, people will make fun of you. But when you're doing more advanced stuff, this is a really great way to try to find the answer to those problems. So, or not answer you at all, yeah. So, and it's just a regular, like, here's all the questions that people are asking and are not answered yet. So, it's pretty good. Maximum likelihood estimation in MATLAB with multi-regimens. That's actually your homework assignment. I asked that one. My name is user 3799380. Anyway, stupid jokes. Okay, so that's some of your homework. Brief touching on the file system API. Let's talk about what exactly this file system like require thing module stuff is. So Node organizes code in modules. There's very few items available in the global namespace in Node, so like console.log is available. This require statement is obviously available, but almost everything else is hung onto a module. A module is just a collection of functions and data. That's all it is. Functions and data stuck inside a single file and made available using this require statement. And it's usually related functions and data. So everything that has to do with the file system is in the FS module. Everything that has to do with HTTP, so making connections to other computers like a web browser or starting a web server, is in the HTTP module. Everything for dealing with URLs is in the URL module, paths, the path module, and so on, right? Just a way of organizing this code. And then we can get access to it using this require. If you've done programming in any other language, it's like libraries and frameworks, basically, right? You import stuff or you require stuff or whatever. Every language has a way of organizing your code into multiple files and making it available somehow. Include in C, right? Always assign the result of calling require to a variable. And as a practice, you usually assign it to a variable with the same name as the alias for the module, right? So, and then the code and data and whatever else is hung onto that module as if the module is an object. So you can use dot notation, fs dot whatever, yeah, http dot whatever, path dot whatever, and so forth. So let's look at another module. Let's look at the HTTP module and build a web page or build a web server. So we're going to use Node to make a web server. It's ridiculously easy. I have an error in my documentation. I need to, let's go ahead and look at Node over here and go, okay, how would I do this? How do I do this? Well, Node actually provides an example on their homepage. They're like, here's how you create a web server in Node. So we're basically going to run through that and see how that makes sense. But if I wanted more information about this, I could look at the documentation, as you will certainly be doing for your homework assignments, and go down and look at the HTTP module here. And then I can see all of the stuff that you can do with the HTTP module, right? Specifically, there's this function, create server, that we're going to be using. So, and unfortunately, it doesn't actually include that much documentation, but if you go down and look at like request events and stuff like that, you get a little more information. Let's see how this works. So first of all, I need to require in this HTTP module. Remember, I do that as a string. And I want to assign the results of that to a variable with the same name. So var HTTP equals require HTTP. I want to create a server. That's a function that is on the HTTP module. So we treat it like an object. So I could say HTTP dot create server. And that server is going to take a callback function. We'll get to that in just a second. But I also want to assign the result of this function, which is a server object type thing, to a variable so I can keep track of it. So I'll say var server equals http.createServer. And remember, this is all inside of our documentation for this class's lesson. It's all part of the lesson material, and the sample code includes it in that examples folder as well. So, okay, this createServer function works asynchronously, so it takes a callback. So I need to go ahead and provide an anonymous inline function that is going to do the work of dealing with requests to my server. That is when anybody browses to my server, right? This callback function, according to the documentation, HTTP server, create server is a function which is automatically added to the request event. It takes a request listener, and it's going to look something like this. Function with request and response. So I'll go ahead and add the REQ and RES parameters to my function callback that stand for a request and for a response. Now, we're going to learn a lot more about what HTTP is, so the Hypertext Transfer Protocol, which lets people look at web pages on the internet. We're going to learn a lot more about that in our next lesson when we talk about Express more specifically. For now, we should understand just a couple of things. One, this request object has a URL property that we can access using dot notation. So I could say request req.url, and that tells me the URL of whatever file or resource the person who has just browsed to my server is trying to access. What's a URL? Well, that's a URL, right? So the URL would be node.js.org/API/http.html pound information, right? URL. I can get that from the request. A request is sent from a web browser or from any other program to a server anytime it wants to request an object from the server, like an HTML page or an image or a movie or an MP3 or whatever. Anything that is that the server has available to be served, a request must be made for it, and that comes in the form of a request object. And again, we're going to learn a little bit more about this in our next lesson.
So can I ask, just in terms of apps, which is the Express apps, those aren't necessarily going to be HTTP. Like, I mean, aren't the apps going to be autonomous? But I guess since they're on the server,
it's still HTTP. Underneath the hood, Express uses HTTP. So, but it abstracts out a lot of the functionality that we'd have to rewrite ourselves every time we wanted to make an HTTP application. So yes, so that's why we're not going to dwell on this for too long. Just kind of get the basics of it, and then move very quickly to how Express does it, because Express makes it very much easier. But we do need to understand how HTTP works, because that is fundamental to all web application development. And we need just a brief introduction to it here. So we've got a request. Request comes to our server. Our server handles the request, so it gets that web page or it accesses the database or whatever it does, and it now needs to send a response. So that's what this response object is for. I will call functions on this response object, and it will cause information to be sent back to the web browser. And underneath the hood, the operating system and my Ethernet hardware and wireless networking and routers halfway across the world are handling like all the hard work of how that actually happens. I can just say send this, and somewhat magically it will send it anywhere in the world, right? So basic request response, we're going to learn a lot more about that in our next lesson, but for now that's what we need to know. So I'm going to log whatever URL, anytime this web browser has requested, I'm going to log it immediately. So I'll say console.log request.url. Incidentally, this function is called every time somebody browses to my server. I think I mentioned that, but let's make that explicit. Now I need to send a response back when that user comes to my server. There are two things I need to do. I need to write what are called headers. So there's a function write head on the response object. Express makes this a lot easier, so maybe we don't need to worry about these details, but this is what I have to do. I send the response status code, which is how web browsers and servers know what's going on between them. Is everything okay? Did something freak out? Whatever. I'm going to say status code 200, and then I'm going to tell it in the form of an object. So I'm opening up a JavaScript object, right? What the content type is, and so I say content type colon text HTML. Actually, this could be text plain. And now I've like built up the response headers for my data. Headers are like metadata about my response. They're telling this thing about the response. The actual response, I write with the function end on the response object. So I say response.end, and then I can give it a bunch of plain text. Hello world. And so now every time somebody connects to this server, they're going to get back hello world in plain text, no matter what page they visit on my server. Every page they visit is going to return that. Then I start my server with the listen function, and I want to listen on port 3000 to anything that makes a request to 127.0.0.1, which should sound familiar, right? That's how we've been doing it with Express. And that's it. I just wrote a web server. Yeah.
So you can leave off the host, and you can leave off the header stuff, like the content type, and all you have to return for the head is just like a status, okay. And
so just 200? But does it infer the content type from response.end?
Yeah.
Okay, cool.
Most browsers will do it.
Most browsers will do it?
Yeah.
Okay. So Milo was saying we could get rid of this object here, like that. I'll go ahead and be explicit about it, just so we know. And then for the port, we could leave off the port.
No, you have to have the port.
Oh, but you can leave off this thing. Yeah, then it will respond to any host. Yeah. So that, I guess that supports virtual hosts. Is that what that does?
Well, if you do that, you're just saying local host.
Right. But it's, I mean, it's localhost anyway, so we'll go ahead and leave that one off. But in case we don't remember, right, how do we access our local computer? It's 127.0.0.1, right? What's that? Or localhost. And then I can go ahead and say console.log listening to requests on 127.0.0.1 colon for the port 3000, right? So if I go to that web page, let's put an http colon / in front of it. If I go to this in my browser, I will connect to the server that I have started up on my computer. Yeah. Let's see that in action. So I'll run my node test.js. It says listening to requests on this, and it's waiting. Notice that the program doesn't quit. We're going to talk about this in a second. But now it's waiting. So if I browse to that site on my browser, I get back hello world, which is the code that I just wrote to do that, right? And it logs to the console the fact that I've requested basically the index or blank and my favicon, which every browser does automatically when it visits a site. So if I were to browse to another page on my computer, this is another page.html. I still get back hello world because I only have that one function that's handling all of the requests, but it logs the fact that I asked for another page to the console because that's the request.url, right? Now we've noticed some of this stuff in Express already. We've actually been kind of doing this. This is what Express is doing underneath the hood. It's written this code for us and made it a little bit easier for us to handle some of this stuff. Like we don't have to explicitly write out headers. It's nice, right? Express, we say .html and it figures out the HTML or whatever. But we've got a server. We just wrote a web server. If somebody else in the world wanted to connect to my computer, they could get my IP address and port 3000, and they would see this. This is what they would get. This is running on the internet, right? So, and that's like 10 lines of code. That's why people like Node. So, do that in Java. Maybe you can do it really easily in Java. I don't know. Try to do it in Objective-C. Same thing. Really hard. So, cool. Let's just review real quick to make sure we understand what's going on here. I require the module. I get access to all of this HTTP functionality. I call a function on the module to create a server. That server function, this create server function, takes a callback that will be executed every single time somebody connects to my server. Why does this make sense? I can't know when somebody is going to connect to my server, right? So this guy is going to sit around waiting in the background for somebody to connect to my computer, and when that happens, it's going to call this function. That's what create server does. Sits around waiting for a connection and then calls this function anytime that happens. We need this to be a function because I might write different servers that do different things, right? This is that little part of the algorithm that is specific when the general pattern is creating a web server. I don't want to write the code for that. It's the same code every single time. My response will be different, right? And so then I would log my URL and send out my response, which requires headers and content. And that's what those two guys do there. And then I start my server listening. And it sits and waits for connections in the background. Sits and waits, sits and waits. Yeah?
So when that function is called, though, is it in a loop or something where it just continually keeps doing it?
The event loop.
The program's still...
Yep. So we're going to talk about that in like 2 seconds, 2 minutes.
All right.
Yep, because that's a critical piece of this puzzle for sure. Let's make this more advanced. We know how to read files. We just did that, right? fs.readFile. So let's pull in the file system module. And instead of sending back hello world, let's send back a file. Yeah. Let's send back this file, test.js. So inside my server callback, rather than writing hello world, let's read my file. So I can say fs.readFile. I imported it up here. The file I want to read is called test.js, and it takes a callback function with an error and data. Okay. If I got an error, let's go ahead and send back error or whatever. Otherwise, let's send back data.toString. And notice what we've done here. This is what I was talking about. I have a callback inside of a callback, yeah? Because they're both asynchronous operations. When somebody connects to my server, finally this whole function gets executed. But then I ask for the read file, and that doesn't finish until some point later on when this function gets executed, and I actually finish this ending response. This is why closures are so awesome, right? We talked about how functions carry around the bits of code that they need to execute even later on. That's what's going on with RES. My anonymous function here captures the response object and carries it around with it, holds on to it until that function finally gets executed, this anonymous callback from read file. That's why that can work. I can still refer to these variables up here from inside that function. And so now somebody connects to the server, I read myself, I send that out the stream in my response object, and that's how it should work. So if I save that and restart my server and browse to that web page again, I should get back my file. That's kind of neat, right? Let's do it in another file. I'm going to make an empty index.html. So I touch index.html. I'll open up both of these files here. So I've got my test.js and my index.html. And you know what I'm going to stick in my index.html? Twitter Bootstrap. So I go over to Twitter Bootstrap. That would be amazing if it figured out what I meant from that. I grab, I don't want 2.3. It's a real shame that still shows up at the top of Google. Go to get started. There's a lovely template that I'm going to copy and paste into my index.html. It's that guy there. So I copy that. We know that we need to fix these links, right? There is no CSS, Bootstrap, whatever. How do I do that when I don't have the files on my computer? Well, I can use what's called the Content Distribution Network. Twitter Bootstrap provides links to other URLs that host those files for me, so I can just refer to those. So I'll grab that, stick that in here. Fantastic. Replace my script with that as well. So grab this guy, stick that in here. This part is not really the important part of this. Really, the important part is the fact that we can serve a separate file. I just want it to look nice. Okay, so I have an index.html. Instead of sending back test.js, let's read index.html and send that back. So I save it, restart my server, go back to that web page. Why did that happen? Close. Close. What happened? So that's definitely the HTML right there, but it sent it back. I got toString. Text plain, boom, right? So I'm sending the content type back as text plain, which tells the browser to render it as plain text rather than text HTML. So let's fix that, restart my server, and refresh my page, and boom, I got my Twitter Bootstrap page. Read from a file on my system, inside the same directory as my server, in about 20 lines of code.
That is really cool.
Right?
Yeah.
This should look pretty familiar, like this process. So now imagine, instead of index.html, you have a public folder, and you can stick any file that you want in that folder. And then when you browse to some file on your server, like about.html, under the hood, this node program is figuring out that the URL includes about.html in the path, and then looks for about.html inside the public folder, reads that using read file, and then sends that back out over the application, the web server, to the browser. That's what we've been doing with Express. This is what Express is doing under the hood. Yeah? Only it's made it easier for us to do that because it automatically supports static web pages. And it's not that much code to make it work. So this is Node. This is why we are learning Node for web application development, because it's ridiculously easy compared to learning other ways of doing it. And we do it in JavaScript. Any questions about that? We're going to talk about the event loop in just a second. That's it. Class is, yeah, that's right. Class is done. That was it. All right. Congratulations, guys. Our job fair is actually tomorrow. I'm
Ready for the real world.
Yeah, right? Are you ready for the real world? So, but this is close to what we're going to be doing in the whole class, right? So the rest of it is figuring out how to make it easy for us to send HTML where parts of the HTML change, because we're going to access the database and stick that information inside of the HTML page. And there's easier ways to do that with Express than using the HTTP module. So, but questions about this specifically? This is in the sample folder again. So if we look at our example code on the class and we look at examples, you'll see that we've got this index.html file, which is our Twitter Bootstrap example. And then we have the server.js, and the server has two options. I can create an advanced server or a simple server. The simple server just sends back hello world. The advanced server, so you run it node server.js with advanced at the end of it, will actually send back that HTML file, the index.html. So. I show you how to use it. So in case you're like, what? This, right? Simple usage. I can just do node server.js and I get hello world, or I can do node server.js advanced and it'll send that index.html. But that way you can see both examples of what we covered in class here. Sweet. Okay, so as it was pointed out, my server is still running. My server is just sitting there waiting for stuff to happen, right? My program has not quit yet. That's a little bit different than all of the other Node code that we've written so far. Normally, Node looks at our code, executes everything, and then exits. Node's done. Our program is done. Not the case this time. Our program is still sitting there. It's waiting for people to connect to it, right? This is accomplished with the event loop. An event loop handles and processes external events and converts them into callback invocations. So events happen. They happen in the background somewhere in the system. The system calls back into our code using that callback function that we've provided. In a web browser, events include things like clicking on a button or typing some text or scrolling. That's typically events. They're user events. But they don't just have to be user events. An event can be anything. And so on the server, events are commonly like the completion of a file system operation or somebody connecting to a web server. When a program, and this is the key part here, registers a callback function for events that may occur sometime in the future, Node ensures that the event loop keeps on running while waiting for the event to occur. And so you can imagine that your program is like stuck in this loop, okay? And at some point in the loop, the system gets a chance to say, hey, something happened, right? And then at the other point in the loop, your code gets a chance to do stuff, okay? And so it's like going back and forth in this loop. Hey, system, did something happen? No. Okay, hey, program, you get to execute the rest of your code right now. Hey, system, did something happen? No. Hey, program, execute the rest of your code right now. Oh, you don't have any more code to execute? We reached the end of the file? That's okay. Hey, system, did something happen? No. Hey, system, did something happen? No. Hey system, did something happen? Yes. Oh, what happened? Somebody connected to me. What am I supposed to do? Call a callback. And that contains some code that handles that event that just got injected into our application from the system, the callback invocation. Okay? But otherwise, our application is literally sitting there in this loop, waiting for things to happen. And as long as we have a callback registered for a possible future event, it's going to stay in that loop until we quit the application or it crashes. Okay? So that's what the server is doing. It's waiting for events to happen. This is called the event loop. And it is built into JavaScript by default. The event loop is in the browser as well. In fact, that was why Node was originally chosen for asynchronous file operations, because the event loop makes a lot of sense, particularly since JavaScript already supported callbacks as well. It's like, oh, I can write this thing underneath the hood and then use the event loop and callbacks to let the application know when stuff happens. That's really smart. So that's how that works. Insofar as that really explained anything, but that's like the really high-level picture, right? So.
Can you have multiple event loops running asynchronously at the same time?
Not in JavaScript, to my knowledge. There are other application environments like Objective-C, which is for iOS and macOS programming, that support multiple event loops. So I think each thread runs in its own event loop, and then events can happen on separate threads, but we don't deal with separate threads in JavaScript, so I think there's only one event loop in JavaScript. All right. Sweetness. Let's see if we can finish the material up. We're going to get really close. I think we actually will, because the last 2 pages is just examples of stuff. I think this is the last thing that we're covering for this lesson. We've seen, excuse me. That was rude. I'm so hungry. We've seen that we have modules, and that the system provides built-in modules, and that we can just require those modules and use them in our code. At some point, our application is going to get large. It's going to be like thousands of lines of code. So if you're like, I'm never going to write thousands of lines of code in my life, yeah, you will. And it'll happen very quickly. I bet you we write 1,000 lines of code for our project, easy. Right now we're at 22. Once you start to get into the hundreds of lines of code, you get lost in your code. You really need a better way of organizing things. And typically you want to take stuff that's related, that has similar functionality, and put it in its own file. Node lets us do that. And every file that we put code in is a module automatically. Any file more than the main file for our application, and including the main file for our application actually, that contains code is treated like a module. And we can just require it in to the main application using the require statement and access the functions that we define in it using the same dot notation on whatever object we get back from the require statement. So let's see how to do that. I'm going to open up a new file here because my server is just so pretty. So quit that. I'm going to touch a circle.js file. And so circle.js, imagine that circle.js is a module for handling circle geometry, so calculating like the area and the circumference of a circle. And that's code I might use a lot, so I'm going to stick it in its own file and then require it into my main application when I need it. So I've got circle.js. It's going to do a couple of things. I'm going to grab pi from math.py. Math.py is a built-in JavaScript object that contains pi. And then I'm going to calculate, so provide a function called area that takes the radius and returns pi times the radius squared. So pi times r. That's our function for the area of a circle, right? And then I'm going to write a function circumference that takes a radius and returns back pi times 2 times r, if I remember correctly, right? Okay, so there we go. I now have this file, circle.js, that I can require in another part of my application, and that will have access to these functions, as we'll see in a second. So let's make another file here. I'll call it touch calculator.js. Calculator.js. Okay. And from my calculator.js, I'm going to import or require. Import is another word I'll use for this sometime, but var circle equals require. How do I refer to my own module, my own file? I can't use this alias. Instead, I use the file name. So I can just say circle. And I don't even have to put .js. It's just the file name without JS. But I should indicate that it is relative to the current directory. And how do I do that? So this is actually a file path. Dot represents the current directory, and / shows that it's a directory. So we say dot / the name of the file I want to include, right? That's it. And so I could have, if I had a subfolder, say circle was in another folder called objects, whatever, then I would say dot / objects circle, right? I'm just literally using a file path here. So we can do that. All right, boom. And so now I should be able to calculate the area of a circle. I could say bar area. I treat my functions just like they were on objects. So I've got this area. So I say circle.area, pass it a radius, console.log area, and that should work. It's not going to. We're going to find out in a second why. But let's run it. So I could say node calculator.js, and I get this object has no method area. All right, what gives? I required circle. That seemed to work correctly. My circle module here definitely has area, but I have not exported that function from this file. JavaScript, or Node specifically, treats every file in your application as a separate context. Every file has its own scope. Excuse me, not context, scope. So things that I define in one file, even though they're defined in the global scope, are not available in other files by default. That means that things in files in Node are private. Other things cannot, other parts of the application cannot get to them, unless I explicitly export them. And so part of defining a module is choosing what you want to make available to other parts of the application. That's called exporting it. Every module has an exports object on it. And so then I can assign functions and data to properties on this object. So treat this like it's an object. And I can say exports.area equals my area function. So area is in my global scope in this file, right? And I'm basically saying exports dot, like it's an object. Here's the property name, and I want it to be my function.
So you would do that
For each function that I want to export, right? So I can say exports dot circumference equals circumference. Now I'm explicitly, yeah.
No, go ahead. I was just gonna say like an easier way, rather than doing it all at the bottom.
We'll do it the other way, yeah. So I'm gonna, and then I include that in our sample code as well. So. But real quick, let's show how this works, and then we're going to do what Maya was talking about here. So I'm explicitly exporting this stuff. Now if I run my application, boom, it works. There it is. I made area and I made circumference available from this file or from this module. Yeah. And now I can organize my own code however I want. I can stick functions inside separate files. I can require them inside other files, and then I can get access to the functions that I export using this dot notation. So what Maya was talking about is it might be kind of silly to explicitly define the function area and then assign it to exports. What am I doing here? This is that same thing where like I assign something to a variable but then immediately use the variable. I might as well just assign it the function directly. So I could say cut that out, assign that to this, and then now this guy doesn't need a name because dot area is its name. It's a little bit easier, right? But it's effectively the same thing. I can do that with circumference too. Boom. And so that's real. You'll see that pretty often, right? And then if I want to, oh yeah, I know there's another way to do it. You want me to show the other one?
Yeah. Okay.
Yeah.
I was gonna point
the module.exports.
Well, not that. Yeah, but also you can just export from one object and have all those be properties
On that one, right? Yeah. But module.exports is usually how I see that done. So you say module, because you have to do it through module specifically. If you just try to do it through exports, it doesn't work. You get the code won't compile.
Well, exports is actually just an alias for module export.
That's what I thought too, but I swear last time I tried it, it didn't work. So, but we'll I mean, it's good enough to learn the one sort of method of doing this, and then you'll see in our sample code that there's other ways of doing this as well. So, and now if I want to have private functions, so like pi is not available outside of this file. There is no circle.py. Because I don't explicitly export that. That code will fail. That code will crash right there. Yeah. If I want to make pi available, I have to explicitly export it. Exports.py like that. No. I don't know why the syntax is weird there.
If you do that on the actual file, wouldn't the functions be available? Do you still have to do exports on each function?
Well, sorry. So what do you mean?
So if you put the exports for your Pi for that file, right?
Right.
You still have to do the exports.
That's a good point.
Area?
Yeah, good point. So like, where is Pi here? So this Pi is no longer defined globally or inside of this file anyway. It doesn't live on this, and I don't know if I can do this. So you're talking about like doing that?
No, I was thinking if you didn't have.
Yeah, that's a good question.
Area.
I'm not sure. Mayo, do you know offhand?
I'm not sure I understand the question.
So yeah, so check it out. I refer to Pi inside of these functions, but Pi is now part of exports. Pi doesn't exist inside of the scope for this file anymore.
So could you just have area equal function and not have exports in front of each function?
No, you still have to have exports in front of each one. Okay. So, but where does Pi live now? Is Pi on this? I don't think so. I don't think you can access your own exports from inside the file. Oh, apparently you can. So there you go. This does not work. I've tried this before. This does not. So if let's say, check this out. So what if I was tricking you? And exports looks like it's an object, right? So it looks like I should be able to call this on it. So I say, I'm tricking you. This actually calculates circumference, right? Which you think would work because I'm just calling the circumference on this exports object, right? I swear I did that and it didn't work the last time. Great, that's fantastic. Maybe it doesn't work when I do module.exports. So let me show you the shortcut for doing this as well. Rather than saying exports dot equals, exports dot equal, exports dot equal, we can do this in one fell swoop. I've always seen it as module.export, so I'm going to try that one first, and then we can try it the other way. You say module.exports equals, and you assign it an object. And then on that object, you provide all of your named functions. And so this is like a normal object, and I could say pi is math.pi. Then area is a function that takes r and does return. You would think this.pi, and this is what I swear is going to break here, .r, right? And then comma, circumference is a function, r, and returns this.pi times 2 times r. And then I don't have to say exports dot like that all the time. I can just do it in kind of one swoop like this, right? That's another way of doing that. Yeah?
On your page, you don't have pi in the module export.
That's true. I have it declared locally as I was doing originally. And let me try to run this and see if it works. This is where I think still seems to work.
Well,
so
can you call it from your calculator?
It is being called from calculator. So because I'm requiring circle, any changes I make to circle are automatically reflected by the calculator, right? And I'm actually running calculator. So let's try this dot circumference. Cool. I swear when I did this didn't work. And so then, Maibo, you're saying I don't actually need module. I can just do that, right?
Well, I assume it works because like exports is the way it's written is really just module exports equals, and then the object. So they're just assigned to each other.
To each other? Yeah. So let's see. Has no method area. No, see that one? So for some reason, if you want to do it in one swoop like that, you got to put module in front of it. And I've never understood why. So, but I think I think all of that extra explanation sort of muddles it. What we're really doing is being sure that we export any functions that we define from the module, however you want to do that, right? So this should work now. Yeah. Okay, does that make sense? It's a way of organizing our code. Okay, so that's it. That's a really basic but important introduction to Node. So Node has some major topics that we need to understand, like the event loop, like asynchronous programming, and like modules. And we need to understand that there are built-in modules that we can access, and we should learn about them from the Node documentation, and that we can create our own modules. What we're going to learn about in our next lesson, one, how to use third-party modules, So other people can build modules, and we can download them into our applications. So they're called dependencies. We kind of learned about that at the very beginning. And we're going to learn about the most important third-party module that we're going to use for the rest of this class, Express, which is just a third-party module. It's a collection of code, just like we're writing our code here. We can require it into our application. If you look on our OK Coders, the class material for this class, so Node Introduction class and Intro to Node, at the very bottom you'll see a reference to some important APIs. And so, like, here's the modules API, and it shows the different ways that we could do this, right? So that's basically what we were doing right there at the end of the class. Here's the file system API and an example of using it. Here's the path API, which you're going to need to use in your homework. It's for building paths. So because directory separators, are treated differently on some operating systems, rather than hard coding them and your application not working on Windows or Linux, depending on where you program on, you should use path.join, and it will turn it into a correct path. And then HTTP, of course, is for creating servers. Our homework assignment is significant. So you have a big homework assignment today. You've got, I guess, 5 assignments to work on. The first one is just a modification of our simple file reader. Make it so that you can read any file instead of hard coding it, right? They can choose it from the command line. Our second assignment is move that file reader to its own module so that you've got a module that you can carry around, and then call it from a separate application file. And I've templated this stuff out for you and told you which files you need to fill in. So, assignment 3, write a program that will copy a file to another file. Be careful not to overwrite files on your computer. So after I did that, I was like, maybe that's a dangerous assignment. Keep it, specifically to the test to see if you can get that to work, and then you won't break anything. So, assignment 4, build or modify the server that we've built in class to serve index.html so that you can serve any file inside of a public directory. Basically, build what Express does with static files. What you're going to have to do is learn how to look at, and you'll have to look at the documentation, but you'll need to extract information from the request.url to get its path, add that path to a public path, because all of your files are going to be stored in the public directory. Read the file inside of that public directory. If it exists, check if it exists first. If it doesn't exist, send an error back. If it does exist, read it and send that back. Yeah. And this is actually not a lot of code. It's probably about as much code as this right here. So it's only like 20 some odd lines of code, but you're going to be using paths, URLs, HTTP servers, and the file system APIs, and you're going to have to do all the research in the documentation to figure out how to do that. And that is what will take you time, reading the documentation, not so much writing the code. So, but that's intentional because, everything else that we're doing is just understanding documentation and then just writing JavaScript for it. So that's what we really need to practice. But expect it to take a few hours for sure. So, okay, any questions? So welcome to Node. We're finally getting to the point where we can start building interesting things. So, all right, guys, thanks. And let's wrap it up and move it out here pretty quickly because I got to lock the door. Everybody is gone. So, and let's take some of this stuff down too. Normally they do it for us.